Hello guys, today I'm going to tell you how to solve the question from aviation database. This is a flight monitoring subject for FPL training. We see the number of this question is 35831. I found this question interesting for me because first of all we need to find two aerodromes. We have coordinates. It's somewhere in northern hemisphere in Europe, just a bit to the east from Great Britain. So one aerodrome is in Austria, another in Germany. Okay, let's try to find it. First of all, we see the latitude. This is 48 degrees and 31 minutes. So let's look through the charts. First of all, it's a good idea to be familiar with that chart. Uh, it, that will be much faster to find those airfields during your ITPL exam. But anyway, we see here two latitudes, and let's look to the first. Here is 48 degrees north, but we have 48 and 30 minutes. So going further mm, uh, to the north and looking for the 48 degrees and 30. Okay, here it is. The latitude is just over there. We are looking airfield just a bit north to that line. We are looking for longitude 14 and degrees and 30 minutes to the east. Here we see east 13 and 30 minutes. That is why we need to go further to the east. You see here is 14 degrees, and here is 15, I believe. Here it is 14 and 30 minutes. And by the way, actually I found this airfield, Lima Oscar Lima Foxtrot, and this is good idea to round it with a red circle. Okay, next airfield is on the same latitude, just a bit to the north. Here is 31 minutes, and here is 31 and some seconds, and we have here 14 degrees of east, and here's 13 degrees of east. So we are going to the west because longitude decreasing. So going to the west, and here is our field Echo Delta Mike Foxtrot. Okay, putting here a circle. Okay, next we need to find magnetic track. Without calculation I can see that there is 270 degrees true track, and if we needed to find distance we would use this calculation. You see here some numbers. You just need to remember it, and after that to put the same numbers uh, over longitude to find the real distance by multiplying by 60 nautical miles for 1 degree of longitude. But in this question we just need to find magnetic track. So magnetic track, for that purposes we have several tools here. First of all, and the most easy, the easiest one is to find this kind of dashed line with variation. We see 3 degrees eastern variation. It means that if we go to the true north, we will see the needle deviate to the right, to the east. So that's why we need to use very good table from explanation. I think this table deserves to be printed out and put just in front of you on your desk, just to memorize it as much as possible. So forget about this calculation, just over there, that kind of picture. So we have true, which is 270, and we have variation. 3 degrees east means plus 3 degrees, and if we 270 plus minus 3, we can understand that 267 magnetic course. Okay, yeah, don't put here next question, just let's continue. Another way to understand the variation is to use this tool, measure angle. First of all, we need to put some line just nearby any viewer, because viewer in that latitude will show us magnetic course, not true course. So let's do it. First of all, we need to put somehow like this one. Okay, let's do it. Just count these points: 1 2 3 4 5 6 7 8. Okay, let's do it here. 7 and 1 2 3 4 5 6 7 7. Okay, this is our true course. This is our true south to north. Actually, it would be a great idea. Okay, let's measure the variation from this viewer and from this viewer. First of all, put line just parallel to our true parallel, and then oh, correct, parallel to our true, and another one parallel to this needle. And you see, with my error, we have 4 degrees deviation to the east. Okay, let's do the same on the 3 strand viewer, Foxtrot Romeo Echo viewer. A plus or minus 1 degree. Okay, here it is, 3 degrees eastern. You see the difference? Okay, wrong method is to use this particular line. Actually, I don't know what does that line mean. I think that line means nothing. It's just here uh, to put some mess in your calculation, you know. So okay, let's try to put here. And another way, another mistake, if you are trying to measure variation with the dashed line. Uh, okay, let's do it. Let's do it. If you here and here, you see this is uh, kind of truth, but that is not true because uh, it deviates to the west, not to the east. But anyway, we have almost 3 degrees deviation. Another one method to calculate variation is to use this dashed line in this way. Here we see almost 7 degrees variation to the west. So those are two incorrect ways to measure calculation. The best way here to find either this value of variation, local variation, or the best way here to find variation with the viewer facility just nearby the airfield. Also, there is a difference if you are flying, for example, here's 3 degrees deviation and here is 5 degrees eastern deviation. So your course would be more with this deviation. But purposes of that question, we have only one 3 degrees deviation. Okay, that is the answer. Yeah, and that is correct.